Hey everyone, welcome back. Today we're diving into something pretty cool. It's called in-class exercises, or ICE for short.
ICE.
Yeah, exactly. You sent over this news piece from Universiti Malaysia Sabah.
UMS.
Yeah, UMS. And they're doing some really interesting things with this ICE approach. And it got me thinking, imagine if instead of just, sitting through lectures, you actually learn by tackling real world problems, right?
Right.
Working in teams, using simulations.
Hands-on.
Yeah, exactly. Hands-on learning. That's the whole idea behind ICE.
And what's fascinating is that UMS isn't, just kind of throwing this out there willy-nilly.
Right.
They've actually developed a whole framework.
Oh, wow.
It's called UMS Alien, which stands for Active Learning in Engineering Education News.
Okay.
So it's really about this shift, moving away from passive learning and getting students to be more active in their education.
So it's like a whole philosophy of how to teach engineering.
Exactly.
Not just a few activities here and there, but like a whole approach.
Yeah. A whole shift in thinking.
But I'm curious, how does this ICE thing actually work in practice? What does it look like in the classroom?
Well, the article gives a really good example with their process simulation and integration course.
Huh.
And in this course, students learn how to use this software called Aspen HYSYS.
Aspen HYSYS.
Yeah, it's like the industry standard for simulating chemical processes.
Oh, wow. So the real deal.
Yeah, the real deal. So, the students start with some self-paced learning online just to get the basics.
Okay, get that foundation.
Yeah, get the foundation, and then that's when ICE kicks in.
So they learn the theory, and then they actually get to use it.
Exactly.
To practice.
Exactly. And it's not just messing up. They have very specific challenges.
Oh, okay.
The article talks about week 1.
Okay.
Students are given the task of designing and simulating 2 different systems in Aspen HYSYS.
Wow.
And they're given specific conditions they need to meet, like temperature, pressure, flow rate, even the type of equation they need to use.
Oh, wow.
So it's like a puzzle.
It's like a puzzle. Yeah.
Where they have to apply what they've learned to find the solution.
That sounds way more engaging than just sitting in a lecture hall, taking notes.
Oh, absolutely.
I can see how that would help the concepts really sink in.
Yeah. You're actually doing it.
Yeah.
You're not just hearing about it.
Right. You're not just passively absorbing information.
Okay.
You're actually applying it.
You're applying it. You're problem solving.
So it's like active learning in the true sense.
Yeah, exactly.
But, what about the bigger picture? I mean, the article mentions some pretty impressive advantages of ICE, beyond just making it more engaging for students.
Yeah, one of the biggest ones is that it really forces students to think critically and to problem solve.
Okay.
It's not about just memorizing formulas. It's about figuring out how to apply those formulas to real world scenarios.
Right.
And those scenarios can get pretty complex.
Right.
Which is where teamwork comes in.
Right, because engineers don't work in isolation.
Right, they don't work in a vacuum.
They got to work together.
They have to collaborate. So ICE gives them a chance to actually practice those skills.
Yeah, from the get-go.
From the get-go. They learn to communicate their ideas clearly. They have to listen to different perspectives and work together to find those solutions.
So it's building both the technical skills and those soft skills.
All soft skills, yeah.
That are so important in any field, really.
Absolutely.
Communication, teamwork.
Yeah, essential skills.
I'm starting to see why UMS is so invested in this approach.
Yeah, it's really about preparing students for the real world.
And it's not just about the skills, it sounds like. ICE also helps with engagement and knowledge retention.
Oh, absolutely.
Think about it. When you're actually involved in the learning process, you're way more likely to remember what you've learned, right?
Absolutely. You're not just passively listening.
Right.
You're actually doing it so it sticks with you.
You're applying it, you're experimenting, you're probably even making mistakes along the way.
Exactly. And that's another key advantage of ICE. It provides a safe space for trial and error.
Well, that's interesting. Tell me more about that.
So, in a traditional classroom setting, making a mistake can be seen as like a failure.
Right.
But with ICE, it's part of the learning process.
You're encouraged to make mistakes?
Encouraged to make mistakes because that's how you learn.
And it's a safe environment to do so.
Exactly. There are no real-world consequences.
Right.
So students can take risks, they can try different approaches, and they develop that growth mindset.
That's so important.
It is.
It ties back to that UMS Alien framework we talked about, right?
Yeah.
They're really trying to shift the whole culture of learning in engineering.
Yeah, they're at the forefront of this movement.
It's pretty impressive, but I'm wondering, is this just happening at UMS, or is this part of a larger trend in engineering education?
Well, UMX is definitely ahead of the curve, but they're not alone. Yeah, there's a growing movement globally toward active learning and engineering education.
Oh, wow. So it's really catching on.
Yeah, organizations like the National Academy of Engineering in the U.S., they're actually pushing for, more hands-on project-based learning.
So it's like a paradigm shift in how we think about teaching engineering.
Exactly.
That's really exciting to see. But let's go back to ICE for a minute.
Sure.
The article really highlighted its impact on critical thinking and problem solving.
Yeah.
Can you kind of unpack that a little bit more for us? What does that actually look like in practice?
Yeah, so, ICE isn't just about like finding the right answer.
Right.
It's about learning a process.
Yeah.
Like how to approach a problem systematically, how to break it down, how to analyze the data, and then make informed decisions based on that data.
So it's like they're learning a mental framework for problem solving that they can then apply to any engineering challenge.
Exactly. And that's a skill that goes beyond just, any specific software or technical knowledge.
Right.
It's about those foundational cognitive skills.
Yeah, the fundamentals.
The fundamentals that are essential for success in a field that's, constantly changing.
Right, because engineering is always evolving.
Always evolving.
New technologies, new challenges.
Absolutely.
Those foundational skills are even more important.
More important than ever.
And what about those soft skills we were talking about earlier,
Yeah.
like teamwork and communication? How does ICE help students develop those?
Well, in a traditional classroom, you might have students working on assignments individually.
Right.
Maybe even competing against each other.
Oh, yeah, grades.
But with ICE, they're forced to collaborate.
Uh-huh.
They have to figure out how to divide tasks. They have to share their ideas, and they have to negotiate solutions.
So it's like a microcosm of a real engineering team.
Exactly.
That's really cool.
And that's where the communication comes in. They have to learn how to articulate their thoughts clearly, both verbally and in writing. And they have to learn how to listen and understand other people's perspectives.
That's so important.
It is.
So it sounds like ICE is creating a much more dynamic and collaborative learning environment.
Yeah, it's definitely a shift from the traditional lecture format.
But I'm curious, does this approach have any downsides? Are there any challenges to implementing ICE effectively?
That's a great question. And, it's important to acknowledge that ICE isn't a magic bullet.
Right.
It does require more preparation from the instructors.
Okay.
They have to design those engaging activities, they have to provide clear instructions, and they have to be ready to facilitate discussions, provide guidance.
So it's not just about letting the students loose and, hoping for the best.
Right. It's a more active role for the instructor.
More hands-on.
More hands-on, but the payoff can be huge. The article talked about better engagement and knowledge retention.
Yeah.
Do you think that's actually the case?
Well, from my own experience, I know that when I'm actively involved in something, I'm way more likely to remember it.
Right.
And I bet that's even more true for something like engineering, where it's so hands-on.
Absolutely. It's not just theoretical.
But what about that software they're using? The Aspen HYSYS?
Yeah.
Is that just a gimmick, or does it actually add value to the learning experience?
Oh, it's definitely more than a gimmick.
Okay.
Remember, this is industry standard software.
Right.
So by using it in the classroom, the students are not only learning the theoretical concepts, but they're also gaining practical skills that they can actually take into the workplace.
So it's like bridging that gap between theory and practice.
Exactly. And that's one of the key goals of active learning.
Right.
Making sure that students aren't just learning, facts in isolation,
Yeah.
but they're also developing the skills and the experience they need to actually succeed in their field.
This has been so insightful. I mean, ICE is clearly a powerful approach to engineering education.
It is.
It fosters critical thinking, teamwork engagement, and that connection between theory and practice.
Right. It's a whole package.
But what does this all mean for our listener?
Well, it raises a really interesting question. If IC is so effective in engineering, could it be applied to other fields as well?
That's a great point. I mean, we've been talking about the benefits of active learning.
Yeah.
But could this approach work in subjects like, history or literature or even the arts?
Absolutely. I think the principles behind ICE, they can be applied across disciplines.
Okay.
It's all about getting students engaged, right? Getting them to participate actively in the learning process.
Right.
So you can imagine like history students debating, key events from different perspectives.
Oh, that'd be interesting.
Or literature students, analyzing texts in groups and then presenting their interpretations.
It's about bringing those subjects to life, right? It's not just memorizing facts and dates, but like actually grappling with the ideas.
Exactly. And that's where active learning, really shines.
Yeah.
It's not just about the content. It's about those skills they develop. Critical thinking, problem solving, communication, collaboration.
Right. Those are essential for any field.
Any field. It doesn't matter what the subject matter is.
This is making me think about my own, learning experiences. And I'm like, man, I wish I had more of those hands-on opportunities.
Yeah.
Especially in those subjects that felt, kind of dry or theoretical.
Well, it's never too late.
That's true.
You can always adopt a more active approach to learning.
Okay.
Even outside of the classroom.
Right.
You can find ways to apply what you're learning.
Yeah.
You can engage in discussions. You can challenge yourself with, real-world problems.
That's a great point. So what can our listener take away from all of this? Whether they're an educator, a student, or just someone who loves to learn.
I think the big takeaway here is that active learning, it has the potential to really transform education. It's about moving beyond that passive absorption of information.
Right.
And creating those engaging, interactive experiences that foster, deep understanding and those essential skills.
And it's not just about, copying ICE, exactly.
Right.
It's about embracing those principles behind it.
Principles, yeah.
Active engagement, problem-solving collaboration, and finding creative ways to apply those to different learning environments.
Exactly. It's about asking ourselves, how can we make learning more meaningful? How can we make it more engaging? And how can we make it, more relevant to the challenges and opportunities that are out there?
That's a great question, and a great note to end on this deep dive into ICE. It has given us a lot to think about.
Yeah, it has.
It's exciting to see how these innovative approaches are, shaping the future of education. And who knows, maybe we'll all be learning through simulations and, real-world challenges in the not-too-distant future.
I hope so. It's definitely a step in the right direction.
Well, this has been fantastic. Thanks so much for joining us today for this deep dive.
My pleasure.
And to all our listeners out there, keep those questions coming, and we'll catch you next time for another deep dive.